All right, the second type of problem that you have to be able to solve is in log form. So these equations are in log form. And what we're going to use to help us solve these is the fact that when you have a base to the power of m and that's equal to the same base power of n, the exponents have to be equal. And we have the same base here. We have base 9, we have base 9. And if we have this base 9, then 9 to some power has to equal negative 11x plus 2. I'll just call that a. And then 9 to some power of b has to equal x squared plus 30. Well, if a equals b and 9 equals 9, then these expressions themselves have to be equal to each other. So basically, if you have a log with the same base on either side of an equation, then we're allowed to drop the log and just solve this equation. Now, your solving could be any methods of solving from any grade you've learned. Any method of factoring, any method of solving is going to happen here. So this guy here is a quadratic. So when I have a quadratic, I get it set equal to 0. So I have x squared. I'm going to move the 11x to the other side. I'm also subtracting 2. So I have 28 equal to 0. And I'm going to factor that. And my factors are still set equal to 0. So numbers that multiply to give us 28, add to give us 11 are going to be 4 and 7. So x plus 4 equals 0. I always set my factors equal to 0. So x would equal negative 4 and x would equal negative 7. Well, you have to take into account your arguments and what would make those arguments positive here. So negative 11x plus 2, what will make that positive? So if I have 2 is greater than 11x, divide by 11. If x is less than 2/11, I know that this is going to work. And then the other guy, x squared plus 30, if I set that greater than 0, well, that's a quadratic inequality, so I treat it as is. I get x squared equals negative 30, so plus or minus the square root of negative 30. That's not going to be solvable. So really what I'm thinking of here is that the only value that could possibly make this 0 would be is if I had the square root of 30 or the negative square root of 30, because if I squared, let's say I squared that, that would be 30, that would be okay, that would be okay. So again, I'm trying to think of like what values wouldn't work here. Every single value is going to work. So this guy here is all real numbers. Nothing really stops that. So what we have here are two values that seem like they're going to work in our problem. Now, if we're not sure about that, then we should take each one. Negative 4, negative 11 times negative 4 plus 2, and I'm going to see if that's equal to log base 9 of negative 4 squared plus 30. All I'm doing is checking to see if these numbers are going to work here. Log base 9, negative 11 times negative 4 is positive 44, plus 2 is 46. And I'm seeing if that's equal to log base 9 of 4 squared, which is 16, plus 30, 46. That guy works. The other one, if you want to check, and you do have to check these ones, log base 9, negative 11 times negative 7 is positive 77, plus 2 is 79. Log base 9 of 7 squared is 49. 49 and 30 is 79. Those definitely work. And again, you can look at your arguments to try to figure out your domains, or you can substitute your values in to see that both of those work. And I do need to see a check of some sort. All right, now this guy has an addition sign in here, And we learned from our powers, our properties and rules the other day, that addition means multiply. Well, what are you multiplying? You're multiplying the arguments. Now, that's log base 6, log base 6, log base 6. Again, I'm going on the, if the bases are equal and the exponents are going to be equal, those expressions have to be equal. So, I'm going to rewrite this. X plus 4 times x minus 2 equals 4x. So all I'm doing is, because I have this addition sign, here, I'm turning it into multiplication there. Alright, so this guy, I multiplied out x squared. It's going to be plus 2x minus 8 equals the 4x. And then subtract 4x, so I have x squared minus 2x minus 8 equals 0. I'm going to factor that. Again, numbers that multiply to give you 8 add to give you 2. So x would equal 4 and x would equal negative 2. Now again, if I look at my arguments, x plus 4 has to be greater than 0. X minus 2 has to be greater than 0. Basically, x can't be negative 4 and x can't be 2. Alright, so again, if I want to take a minute and do log base 6 of 4 plus 4 is 8, plus log base 6 of 4 minus 2 is 2. Is that equal to log base 6 of 4 times 4, 16? Well, 8 times 2 is 16, so this would be log base 6 of 16 equals log base 6 of 16. That would check. Negative 2. Log base 6 of negative 2 plus 4 is 2, plus log base 6 of negative 2 minus 2 is negative 4, equals log of base 6 of 4 times negative 2, which is negative 8. So what do we think here? You guys, you can't have an argument be negative here. You can't have this argument be a negative number. Okay? My argument cannot be negative. So this guy cannot work there. There we go. X is 4 is our only value that works. So you can think of the argument, you can think of the domain, or when you check, you can substitute in and check that way. But again, you got to check these. Alright? This guy here, same thing, but now it's natural log. So natural log, natural log, natural log, they all have base e. So what am I going to do here? I'm going to set up 2x minus 1 times x plus 3 equals x squared minus 3x. So I get 2x squared plus 6 minus 1 is plus 5x minus 3 is x squared minus 3x. Subtract x squared, add 3x, I get x squared plus 8x minus 3 equal to 0 there. Now, that is definitely not going to factor. So, if I check out my discriminant, 8 squared minus 4 times 1 times negative 3, that's going to be 64 plus 12. That's going to give me 76. So even though this guy is not factorable, I can use the quadratic formula. Okay, I can use the quadratic formula to solve this. So I'd be looking at 8 to negative 8 plus or minus. I just found my discriminant all over 2, and I could find those two values. And I can take those two values that I find and I can substitute them into my equation. So I'm not going to go through and keep solving that one. I want to show you this last one here. Again, I have log base 9, log base 9, log base 9. Now this guy here, you learned the other day that when you have subtraction, then you are supposed to be dividing. So what does this look like? You divide the arguments. So I divide x plus 6 over x, and that's equal to 2. Well, how do I solve that? I solve that by cross multiplying. 2 times x equals x plus 6. Subtract x, x equals 6. I'm going to check it. log base 9 of 6 plus 6 minus log base 9 of 6 equals log base 9 of 2. Now again, if I condense these, 12 divided by 6 is 2. That checks. That guy's a solution. So at this point in logs, all I'm doing is I'm rewriting and I'm applying the 3 log rules. You could have the property, but I have to know how to solve these equations. You have to know how to solve these equations. It could be cubics, it could be quartics, it could be any type of solving problem at this point.